In this lecture, I'll talk about the three kinds of claims: association, frequency, and causal. So we'll give definitions of those and some examples of each. So we have three basic kinds of claims here. We have frequency, association, and causal. But first, what do we mean when we say claim? So what does it mean that it's a frequency claim or an association claim? Well, a claim is anything that someone is trying to argue. So your textbook talks about how a politician might be claiming or arguing that they're the best candidate for the job. So it's when someone's trying to make an argument for something. So we have three different kinds. We have frequency, association, and causal. So a frequency claim is going to try to argue that something happens at a certain frequency, or it happens on a certain day, a certain number of times. So a couple of frequency claims we have here. 8 million Americans consider suicide each year. So frequency claims will involve one variable. So here we're talking about how many people consider suicide, one variable. And then we're talking about how many people endorse that. So 8 million Americans consider suicide each year is a frequency claim. We also have association claims. So these will involve two variables. And here we're going to claim some kind of relationship between these variables. So here we have examples. Eating disorder risk higher in educated families. So it's claiming that there's a relationship between two variables: eating disorder risk and the level of education of a family. So that's an association claim, arguing that there's a relationship between two variables. We can have three different kinds of associations. We can have a positive association. So this is when both variables increase. So we might make an association. Actually here, this one, eating disorder risk is higher in educated families. So we're saying the more educated you are, the higher your eating disorder risk. So both variables increase. That's a positive association claim. If we were saying that one variable increases, the other decreases, that would be a negative association. So an example of that might be if we said, the more that you exercise, the lower your fatality risk, or something like that. So we're saying there's a relationship between exercise and risk of dying, and we're saying the more you exercise, the lower your chance of dying. So that's an association claim, and that example is a negative association. We could also claim no association, which would just say, there's no relationship between these two variables. So I'll show a couple of examples when we start to talk about correlation in Chapter 8, where they found some really crazy associations just by chance, really. And so sometimes we'll see association claims and try to make some kind of causal claim. So I've seen probably one of the more hilarious ones is that there's a relationship between the number of lemons that we import from Mexico here in the U.S. and then the U.S. Fatality rate, so while on the highway, so the highway fatality rate. So the more lemons that we import, the lower our highway fatality rate. So that would be a negative association claim. One variable goes up, the other goes down, and so then you could then argue that one causes the other, which would be a causal claim, right? But causal claims, they're really special cases of association claims, and you need some additional criteria to be able to claim that one causes the other, and we'll talk about that here in a minute. But association claims, they're suggesting a relationship between two variables. Causal claims are saying one variable causes the other. So this slide gives an example of a scatter plot. Sometimes you'll see this called slightly different things, but scatterplot is probably the most common. Here we're graphing two different variables, so we have one across the x-axis, another across the y. So this is what a positive association or a positive correlation would look like. So you see as one variable increases, the other variable increases as well, which is a positive association. Remember, with association claims, we're not saying that there's any causality here. We're just saying that there is a relationship. So as one goes up, so does the other. And here we're showing an example of a negative association. So again, one variable is plotted along the x-axis, the other along the y, and we could see that as one variable increases, the other decreases, which would be a negative association. So we're saying that there's a relationship between these variables, and as one increases, the other decreases. We could also have a case where we don't think that there's a relationship between two variables at all, and so that's what we're showing here. In our scatter plot, we have one variable along the x-axis, another variable across the y, and we're saying, you know what, there's no relationship between these two. So that's why you don't see any kind of pattern here. It's just kind of a bunch of dots on the screen. It looks kind of random. You can't really detect any clear as one goes up, does the other one go down? Well, there's really no clear-cut answer there. So this would be a good example of zero association, no association. We might also say no correlation, no relationship here. So we've talked about frequency claims. Frequency claims will tell you how often something occurs. When something occurs, it involves only one variable. We have association claims that will claim a relationship between two variables. It could be positive association, could be negative association, or you might actually claim that there is no association at all. And then we have causal claims, which are a little bit trickier. So I would think of them as a special case of the association claim where we're saying that one variable is causing the other. So to say that we have causality, we need a couple of different things. One of them is covariance. So that means that when variable A changes, variable B also changes. It doesn't matter how they change, so they could both increase together. One could increase, the other could decrease. They could both decrease at the same time. In other words, it could be a positive association, a negative association. It doesn't matter as long as they change together. And that's one criteria. We also have temporal precedence. That's really just a fancy way of saying that one of the variables needs to occur before the other. Just really fancy words. All we're saying is one happens first. We also need internal validity, so again, we'll be talking about validity over and over and over in this course, and then you'll also, if you take statistics, you'll hear about this as well. But you need to find out that there are no possible alternative explanations for the change in B. A is the only thing that changed. Probably the best way to do this is with a solidly designed experiment. Which is sometimes hard to do, which is why causality is sometimes hard to establish. But again, causality, just a special case of association, where we're not only saying that there's a relationship between the two variables, but we're saying that one variable actually causes change in the other. So as you're reading the newspaper or watching TV or whatever you happen to be doing, you'll hear a lot of these verbs. And so it kind of helps to parse them into, what is making an association claim, what is making a causal claim. So here we have some of these listed. Association claims, remember, we're claiming a relationship between two variables, so we might say something is linked to something else. We might say something goes with, is associated with, all of those kinds of words. Remember, claiming a relationship, we're not saying that one causes the other. With causal claim verbs, we're saying that one does actually cause the other. We've met, hopefully, those three criteria that I just talked about. So then we can say variable A causes variable B. it affects variable B, curbs, exacerbates, changes, so on and so forth. So again, association claims, just a relationship between two variables. Causal claims are taking it a step further, saying that we've met those three causal criteria. We have covariation, we have temporal precedence, and we have internal validity. So then we can actually say variable A is causing change in variable B.